Hello guys, welcome to my YouTube channel. In this video, we will build a breast cancer classification system using machine learning. So let's see the types of tumor. So there are two types of tumor. One is benign tumor and one is malignant tumor. So benign tumor are generally non-cancerous while the malignant tumor is cancerous. So benign tumor is generally capsulated. So while the malignant tumor is non-capsulated. So in benign tumor is non-invasive, and but malignant tumor is fast growing. So on the other hand, the benign tumor is slow growing. So in benign tumor do not metastasize, like spread to other parts of the body, while as malignant tumor metastasize it spreads to other parts of the body. So in benign tumor, the cells are normal, but whereas in malignant tumor, the cells have large and dark nuclei, may have abnormal shape also. So all cells of our body divide and grows. Sometimes some of the cells in our body may divide repeatedly without some control in that case. So it forms a abnormal mass and abnormal tissue, and those abnormal mass is called as tumor. So this data set is derived from a test called fine needle aspiration. So this is an example of biopsy test where if a person is suspected to have some tumor, they will try to get some mass from that particular tumor, and they will try to do some test on that particular tumor. So this test is called as fine needle aspiration. So this is the conclusive statement that pathologists take. So pathologist is a person who will basically conduct some test like blood report and will try to find the diagnosis of a particular patient. So now let's move on to the workflow. So we will figure out the data which we are going to work on. And once we have this data set, we will process this data. We cannot feed this raw data to our machine learning model. There are some data pre-processing steps which we'll cover here. Once you process the data, then we need to split our data into training and testing data. We will train our machine learning model using training data, and we will evaluate our model using the test data. Once we do the splitting, we will train our machine learning model. So in this case, we will be using logistic regression model because it is a binary classification case. In binary classification, we are going to classify the data points into two types. Here, two types are one is benign tumor and one is malignant tumor. So which is nothing, we can classify it as 0 or 1. So let's start with our coding part. So first we will import our data set. We will upload our data set. So we will be doing our coding in Google Colab. So you have to upload a data set and just right click on it, click on upload, and your data set will be uploaded. The dataset link will be provided to you in the description box. So let's start by importing the dependencies. Dependencies are nothing but libraries and functions which we are going to use in our code, in our project. So let's start. So import numpy as np, import pandas as pd, import sklearn dot dataset, so from sklearn dot model selection, import print test split from sklearn dot linear model import logistic regression. From sklearn dot matrix will import accuracy score. So NumPy is NP. It is used to create NumPy arrays, and pandas it is used to create data frames or structured table. And this breast cancer classification dataset is present in sklearn. So we will use that. So we have imported sklearn.dataset. sklearn has many dataset inbuilt, so we can just use from that only. So we will be using logistic regression, and this is our evaluation for evaluation purposes. So now let's start loading the data from sklearn. Breast cancer dataset equal to sklearn dot datasets dot load for breast cancer. So our data set has been loaded to, and now let's check our data set. Print breast cancer data set. So this is our breast cancer data set. So now we will be loading the data to a data frame. So that will help for us for data preprocessing. So data frame equal to pd dot data frame. Our breast cancer data set dot data columns equal to breast cancer dataset dot feature underscore names. We'll run it. So now we will see the first 5 rows of data frame. So data frame dot head. So you can see the first 5 rows. There are many columns here. These are the parameters which will help us to detect, to classify and breast cancer. So this doesn't have our target column. So we have to we will be adding the target column to the data frame. So data frame label breast cancer dataset dot target. So now let's check the we have checked the first 5 rows. We will check the last 5 rows now. Data frame dot tail. So this is our data frame. So you can see there is a label column added. So that is our target column. So now let's check what is the number of rows and columns in the data set. So data frame dot shape. So you can see there are 569 data set and 31 columns. And so now we will proceed and get some more information about the data. So data frame dot info. So you can see the all columns and their respective data types, or are in float, and one this label column is in integer value. So now let's check, is there any missing value in our data set or not? So data frame dot is null dot sum. So we can see that our data set is clean and we don't have any missing values. So now we will proceed to do some more statistical measures about the data. So data frame dot describe. So you can see the count, the mean, and the standard deviation, minimum 25 percentile, 50 percentile, 75 percentile, and the maximum of each and every column. So now let's do checking. We will check the distribution of target variables. So like how our target variable is distributed. So we will check that. So data frame So you can see that for benign tumor, we have 357 dataset, and for malignant tumor, there are around 212 dataset. So how we will distinguish between both the tumors? So there is a process. We have to take the mean of each column. So obviously there will be a difference between the malignant tumor parameters and the benign tumor parameter. So let's check that. So for that, we will take the mean. Data frame dot group y our label dot mean So you can see there is a and this one, and one is for benign tumor and 0 is for malignant tumor. So you can see there is a difference in all these values and parameter. This will help us in identifying whether the tumor is benign tumor or it is a malignant tumor. So now we will start separating the feature and target. In Y, I will keep the label. So now let's check the value of print the value of X and Y. So this is the value of X. So let's see the value of Y. So now we will be splitting the data into our training data and testing data. X train, X test, Y train, Y test, I'll apply train test split. The pass the value of X and Y or test size. Let's say 0.2, and we'll give random state equal to 2. So this basically means test size is 0.2 is basically means that 20% of our data set is taken for the testing purposes, and the remaining 80% of our data set is taken for the training purposes. So here random state is equal to 2 means it's just to reproduce the same code, like your way of splitting the data set and my way of splitting the data set will be same. Hence our result will be similar. So let's check how many data sets are splitted in what fashion, means like exact count. So I will take the original data set and I will also print the train dot shape and also the test part, test dot shape. So you can see that almost our total data set was 569, of which 80% like 455 is taken for the training purposes, and the rest 20% that is 114 is taken for the testing purposes. So now we will proceed for model training. So we will be using logistic regression. So model equal to logistic regression. So now we will train our model with the training data. So model.fit will pass the value of X train and Y train. So our model has been trained. So now we will check for the accuracy of on our training data. So X train prediction equal to model.predict. So our X train value. So training data accuracy equal to our accuracy score will pass our Y train value and the X train prediction. So now I will print the accuracy on the training data. I'll pass the training data here. Training data accuracy. We'll run it. So we can see that our accuracy on training data is almost 94%, which is quite good. And let's check accuracy on the test data. So I'll copy this code and replace all with the test data. X train, I have to replace it with X test. I will pass here X test. Test data accuracy. So I will print our test data accuracy. So our test accuracy is coming out to be 92%, which is quite good. So now let's build a predictive system. So I will take the input data. I will take one single value, means a single row data. So I will change the input data into NumPy array. So here I am changing the input data into NumPy array. Then I will reshape the NumPy array as we are predicting for one data point. So we will reshape it as 1, -1 with reshape. So now I will do the model prediction with our reshape data. So I will print our prediction. So if the prediction is equal to 0, so in that case, the breast cancer is malignant. And if it is 1, then the breast cancer is benign. So I will run this. So the given data set, you can see that the breast cancer is a benign. So in this way, you can classify the breast cancer. And that's all from my side. Hope you have enjoyed this video. Thank you.